So here's another way to rationalize the denominator. We'll start with a simple example. I have the cubed root of x and cubed root of 2y. So to rationalize means we're trying to get rid of the radical in the denominator. So to get rid of that radical, I'm going to multiply by the same radical. And the way we can look at this is cubed root means we need groups of copies of 3 to take it out of the root. So right now I have 1, 2. So don't think of the value of 2. I have a single 2. How many more 2's do I need to get it out of the cubed root? So I need 2 more 2's to have 3 2's in total. So I'm going to multiply 2 2's here. And I have 1 y, so I need 2 more y's to get it out of the radical. And then whatever I have down here, I'm just going to write again up here. 2 times 2 is 4, and y squared. So this, I'm going to rewrite this just so we could take a look. On the top, I have 4xy squared. But on the bottom, this would be the cubed root of, now I have 2. So 2 times 2 times 2, and then y times y times y. So for every group of 3, 1 comes out. My final answer will be the cubed root of 4xy squared. So this group of 2, 1, 2 comes out, and this group of y, 1, y comes out. And now we don't have the radical anymore, and that's our final answer. So let's look at just a couple more examples for rationalizing. Now I have the fourth root, but this is 32, so I don't want to multiply by 3 more 32's and then simplify the root. So what I'm going to do is my prime factorization of 32. So off to the side, I have 32. 2 can go into 32 16 times. 2 can go into 16 8. 2 can go into 8 4. 2 can go into 4 2. Okay, so I have 1, 2, 3, 4, 5 2's. So actually we can simplify this root first that's in the denominator. Same with the y's and the x's. So let's do that. So the fourth root of 2 and 1, 2, 3, 4, 5. And the fourth root of, I have 1, 2, 3, 4, 5, 6 2's. Sorry, 1, 2, 3, 4, 5 2's. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So fourth root, I'm looking for groups of 4. So here's 4 x's, 4 2's, and 4 y's. So simplifying first is a good thing to check to see if you can do that. So for every group of 4, 1 x will come out. So just 2x on top. And every group of 4, so a 2 and a y will come out of here. And I'm just left with 2y down here. So now this is easier to work with, just 2y, and it's just like the first one. I multiply by the same root, and I have 1, 2, so I need 3 more 2's and 3 more y's. Whenever I multiply on the bottom, I have to multiply on the top. 2 times 2 times 2 is 8, y to the third. So my answer here on the top will be x, fourth root, of 8 times 2 is 16, x, y to the third, and then that's over 2y is what came out of the root here. So this is what we had before, is this 2y. And then for each group of 4 2's, a 2 comes out. And then same thing with these y's. For each group of y's here, 1 y would come out. Okay, so we actually have some more simplifying to do. Since this is 16, 16 is 2 to the 4th. So 2 to the 4th, that's 2 times 2 times 2. 2 times 2 times 2 times 2 is 16. So we can still simplify the top. On the bottom, 2 times 2 is 4, and I have y squared. So the rest of the stuff we're doing here is just simplifying. 1, 2 would come out from the top to have 2x, fourth root of x, y to the third. And on the bottom, I have 4y squared. and I can reduce this fraction. So 2 over 4 can reduce to 1 over 2 for your final answer. Okay, so let's look at another one. I have the cubed root of x over the cubed root of 4y squared. So I'm going to rewrite this as cubed root of x over, and instead of 4, I'm going to break it down to its prime numbers. 2 times 2 would be 4, and y times y. So I multiply by the same root in the top and bottom. And I have 2 2's, so I just need one more 2 to have 3 2's. And I have 2 y's, so I multiply by one more y to have 3 y's. And I do that in the top and bottom. So this one's much easier as far as simplifying goes. So this is the cubed root of 2xy. And on the bottom, a 2 would come out because I have a group of 3 2's, and a y would come out for the final answer. Okay, and I have one more example here. So 40 is a bigger number. Let's do our prime factorization for that. So I have 40. 2 can go into 40 20 times. 2 can go into 20 10 times. 2 into 10, 5. And 5 is prime. So 5 goes to 5. So I have 3 2's and a 5. So let's see. I will do 4th root of 2x. And I'm going to rewrite this as the 4th root of 2 times 2 times 2 times 5 times x times y. So I'm going to multiply by the 4th root in the top and bottom. So I have 3 2's, so I just need one more 2 to have 4 2's, and I have 1 5. So I need 3 more 5's to have 4 5's. Keep in mind you want to have 4 of everything to get the whole thing out of the root. If we don't do the 5's, we would still have a 5 in the root. So I have 1 x, I need 3 more x's, and I have 1 y, so I need 3 more y's. So whatever I do down here, I have to do up here. So 125 times 2 would be 250. And then x to the third, y to the third. Okay, so now I'm going to multiply 250 times 2. So I'll have the 4th root of 500. And then I have x to the 4th, y to the 3rd. On the bottom, my group of 5 2's, 1 2 comes out. My group of 4 2's, 1 2 comes out. My group of 4 5's, 1 5 comes out. I have 4 x's, so an x and a y comes out. So down here, this will become 10xy, but this 500, let's just double check that we don't have a group of 4 there. So I have 500. I'll start with 5. 5 goes into 500, 100. 5 goes into 120. 5 goes into 24, and I'll do 2 and 2. So I have 3 5's and 2 2's, and so there aren't any groups of 4, so I can't simplify the numerator any further. But this x to the 4th, there are 4 x's, so 1 x can come out, 500 y to the 3rd over 10xy, and now since that x came out, an x can eliminate down here. So your final answer would just be the 4th root of 500 y to the 3rd over 10y. Okay, so just keep in mind, you're trying to, whatever is in your index here, you're trying to get a group of numbers or variables of like that number of copy of times, if that makes sense. So I have the 4th root, so I'm looking to multiply 4 2's and 4 5's. And then keep in mind, once you have your final answer, always make sure it's totally simplified. We don't want to leave it incomplete if we don't simplify it.